Imagine if New York ran out of water. Not temporarily, permanently. Imagine reservoirs shrinking every year, wells drilled deeper, rivers running lower. Now imagine the solution wasn't conservation, or desalination, or recycling. Imagine the solution was moving an entire river. That's exactly what China decided to do. Every year, the country moves 65 billion cubic meters of water, enough to fill 26 million Olympic swimming pools, through canals stretching farther than New York to Chicago, to serve more people than the entire population of Germany. This project is so large that it has no parallel in North America. This is the story of the largest plumbing project in human history. China has a geography problem. Nearly half of China's population lives in the north. Its political capital is in the north. Its industrial base is concentrated in the north. Much of its wheat production is in the north, but most of its water is in the south. The Yangtze River Basin receives abundant rainfall. The Yellow River Basin does not. This imbalance has existed for thousands of years, but for most of history the population was small enough that nature could absorb the pressure. Then China industrialized. Factories expanded, cities exploded, agriculture intensified, groundwater pumping accelerated, northern aquifers began to fall. Some areas of the North China Plain were extracting groundwater faster than nature could replace it. By the 1990s, the problem was becoming structural. Chinese engineers proposed an extraordinary solution. If the water was in the south, move it north. The concept had existed for decades. What followed became the South-to-North Water Diversion Project. Three separate routes were proposed: an eastern route, using existing waterways and canal networks; a central route, building new infrastructure directly north from the Yangtze; and eventually a western route, moving water across the highest elevations on Earth. The goal was simple: move water from the Yangtze Basin into the thirsty north. The scale was anything but simple. Canals would stretch for hundreds of miles. Entire communities would be relocated. Massive reservoirs would be expanded. The cost would eventually reach tens of billions of dollars. The engineering challenge rivaled any modern megaproject. The central route begins at Danjiangkou Reservoir in central China. But here's the problem. Beijing sits nearly 1,000 feet higher than the water source. The solution was not a canal. It was a machine. Thousands of machines. Engineers built a cascade of pumping stations stretching across hundreds of miles. Each station lifts water higher. Each station pushes it farther north. Think of it as a staircase made of concrete and electricity. The water climbs through pumps the size of buildings. It travels through tunnels carved through mountains. One tunnel cuts through 45 miles of solid rock. In other sections, water is elevated across entire valleys on massive aqueducts. The pumping stations alone consume enough electricity to power a city of 2 million people. The scale is almost incomprehensible. The project took more than a decade to complete. Hundreds of thousands of workers were involved. When the pumps turned on, water began its journey north. For Beijing, the impact was almost immediate. A city of more than 20 million people had been pumping groundwater so aggressively that wells were running dry. The city was literally sinking, collapsing into the aquifer voids below. When southern water arrived, the drilling stopped. Groundwater withdrawals fell by 50%. Aquifer levels stabilized. The city stopped sinking. For northern industrial cities and wheat-growing regions, the diversion meant survival. The project worked. Water flowed north. Reservoirs filled. But in solving the water shortage, China created a new problem, a different kind of crisis. Northern China now depends on an infrastructure system stretching across hundreds of miles, a system that moves water through pumps, canals, dams, and tunnels. Each component is essential. Each component is vulnerable. If rainfall decreases in the south, water supply to the north decreases. If the main pumping station fails, cities depending on it face immediate shortages. In 2014, a contamination event in the Central Canal forced emergency shutdowns and threatened supplies to 30 million people. The project solved a geography problem by creating a vulnerability problem. China's water security now depends on infrastructure that must work flawlessly. Before the diversion project, northern China had a natural problem: insufficient water. It was chronic, painful, but localized. Now northern China has an infrastructure problem. 100 million people rely on machines and concrete. They rely on constant electricity supply. They rely on southern rainfall and southern governments. They rely on a system that, if disrupted, cannot be easily replaced. The South-to-North Water Diversion Project is not simply an engineering story. It is a geography story. One half of China has the people, the other half has the water. The project exists because modern civilization cannot move millions of people to where the resources are. So, instead, it moves the resources to the people. Every day, water travels hundreds of miles through canals, reservoirs, tunnels, and pumping stations. Water that fell as rain in southern mountains flows through concrete channels across northern plains. It fills Beijing's taps. It irrigates wheat fields. It powers factories, invisible to most of the people who depend on it. A reminder that some of the most important systems in the world are the ones we never see. And that modern civilization often survives not by solving geography, but by engineering around it. For now it works. The question is, for how long?